You should see this incredible video my friend just sent me. He is on vacation on the Caribbean island of Martinique and saw a volcano. I would love to see a volcano up close someday. But what I want to know is, how did a volcano end up on a Caribbean island? What is the continental drift theory, and what evidence supports it? In order to understand how a volcano ended up in the middle of my friend's Caribbean vacation, we first have to know what scientists have learned about the planet Earth. Scientists believe that 300 million years ago, all of Earth's continents were connected as one big continent called Pangaea. However, over millions of years, the continents have moved and split apart to form the world as we now know it. This idea that our continents have been slowly drifting around the Earth has been around for about 200 years. It gained more popularity in 1912 when a German scientist named Alfred Wegener began to write about it. Wegener was fascinated by the shape of the continents on a map and couldn't help but notice that South America and Africa fit together like pieces of a jigsaw puzzle. Unfortunately, Wegener had no way to prove his continental drift theory, so it was never really accepted by the scientists of his time. In the 1950s and 1960s, 20 years after Wegener died, scientists developed technology that enabled them to map the ocean floor. This mapping led to the discovery of the edges of tectonic plates, massive slabs of solid rock that make up Earth's outer layer. Scientists observed that these huge plates moved very, very slowly over time. The discovery and observation of tectonic plates was one piece of evidence that supported the continental drift theory. More supporting evidence was discovered as scientists studied plant and animal fossils of the same age found on the shores of different continents. Scientists discovered the same freshwater crocodile fossils in Brazil and in South Africa. Similarly, they found plant fossils in Australia that were remarkably similar to those found in southern Asia. Believe it or not, another piece of evidence to support the continental drift theory came in the form of rocks. Geologists found that rock strata, which are the specific layers of rock, in some parts of coastal Scotland were very similar to those found in eastern North America. These similar rock layers found at the tips of two separate continents suggest that the two continents were initially joined together. The continental drift theory is pretty cool when you think about it. Let's review what we learned. Question 1. What name do scientists give to the one big continent that split apart to form the world as we know it? A. Stratosphere. B. Uniworld. C. Pangaea. D. None of the above. The correct answer is C. Pangaea is what scientists called the original continent. Here's question 2. Which scientist was the first to write about the continental drift theory? A. Alfred Wegener. B. Albert Einstein. C. Isaac Newton. D. Louis Pasteur. If you answered A, you know that Alfred Wegener was the first. Question 3. What did scientists discover in the 1950s and 60s as they mapped the ocean floor? A. New plankton species. B. Tectonic plates. C. The Great Barrier Reef. D. Leatherback turtles. The correct answer is B. Scientists discovered tectonic plates. What are tectonic plates? How interesting that scientists believe that our world was once one big continent. As we learn what made this one big continent split into the 7 continents we have today, it is important to remember that all of our Earth systems interact with each other. Sometimes these interactions are tiny in size, while other times these interactions impact the whole globe. These interactions can happen in a fraction of a second, or they could happen over billions of years. Scientists believe that millions of years of very slow movement caused the top layers of the Earth to break apart and form our continents. This slow movement still continues today. But what causes it? First, we need to remember that the Earth is made up of layers: the inner core, the outer core, the mantle, and the crust. Yup, the ground we stand on is the Earth's crust. Deep beneath the Earth, there is a lot going on. The heat causes the mantle layer to rise and spread out sideways. Once it cools, the mantle layer sinks down again. Although this cycle of heating, rising, cooling, and sinking happens very, very slowly, it has a big impact over time. The area that is most affected is the Earth's lithosphere. The lithosphere is made up of the Earth's crust, the ground you are standing on, and the upper part of the mantle. Back when our world was one big continent, the movement of the mantle's heating, rising, cooling, and sinking caused the lithosphere to break into many pieces. These broken pieces are now known as tectonic plates and act as a type of skin for the Earth. Tectonic plates are constantly moving and shifting. Most of the time, this movement is so slow, we have no idea that it is even happening. Scientists believe that the Earth now has 7 major tectonic plates: African, Antarctic, Eurasian, North American, South American, India, Australian, and Pacific. There are many other smaller tectonic plates as well. Even the smaller tectonic plates are massive in size and are thought to be 62 miles thick. Now we know how tectonic plates were formed. Ready to review what we have learned? Here's question 1. What is the name of the layer of Earth that is made of the Earth's crust and the upper mantle? A. Biosphere. B. Granite. C. Lithosphere. D. Geodome. The correct answer is C. The Earth's crust and upper mantle make up the lithosphere. Question 2. How many major tectonic plates are there in the world? A. 5. B. 7. C. 15. D. 36. If you answered B, you know that there are 7 major tectonic plates. Let's try question 3. About how many miles thick are tectonic plates? A. 5. B. 10. C. 35. D. 62. The correct answer is D. Tectonic plates are almost 62 miles thick. What are convergent boundaries? Those thick, massive tectonic plates are constantly moving. As we learned, they aren't fast movers. In fact, most of the plates move only between 1 and 6 inches per year. As they move, the tectonic plates slide across a layer of flowing molten rock that is located just below the lithosphere in an area scientists call the asthenosphere. The plates don't all move in the same direction or at the same speed. In fact, they might remind you of very slow-moving bumper cars because they move in different directions and at different speeds. And, like bumper cars, tectonic plates bump into each other. This movement of the tectonic plates is most noticeable at the plate boundaries. What the plates do when they bump into each other at plate boundaries has the power to shape the Earth's landscape. Sometimes tectonic plates can collide or move together when they meet. These are known as converging plate boundaries. Converging plate boundaries can be areas of important geological activity. Usually, 1 or 2 events happens when the plates converge or collide. The first is that the plates collide in a way that pushes both of the plates upward. This action creates mountains by forcing the lithosphere upwards. So, although tectonic plates move slowly, that movement can create something as impressive as Mount Everest. Other times, when two tectonic plates collide, one plate can move under the other as it is forced deeper into the mantle. This process is called subduction. Sometimes subduction can create volcanoes because when the plunging plate gets deep into the mantle, some of its rock melts and forms magma that can move upward and erupt at the Earth's surface. This is how the volcano on the island of Martinique was formed. The collision of two tectonic plates sure makes an impact on our world. Let's review what we just learned. Question 1. What is the name of the layer of Earth upon which tectonic plates float? A. Asthenosphere. B. Inner core. C. Atmosphere. D. Continent. If you answered A, you know that tectonic plates float on the asthenosphere. Here's question 2. How far do most tectonic plates move in 1 year? A. Less than an inch. B. Between 1 and 6 inches. C. About 10 inches. D. Between 25 and 35 inches. The correct answer is B. Tectonic plates move between 1 and 6 inches per year. Let's try question 3. What do we call the process in which one tectonic plate moves under another? A. Weathering. B. Coasting. C. Subduction. D. None of the above. The correct answer is C. Subduction is the process in which one tectonic plate moves under another. What are divergent boundaries? Not all interactions between tectonic plates end up in a collision. Sometimes tectonic plates that are found on the ocean floors interact by pulling away from each other's boundaries. These are known as divergent boundaries. When the tectonic plates pull further apart from each other at divergent boundaries, new land or crust is formed because the new space between the plates creates an area where liquid rock, called magma, can rise up from the mantle. The magma cools at the surface, creating new crust area. Sometimes when plates move apart or diverge, rift valleys can be created. These lowland regions can be found on land, as well as at the bottom of the ocean. The motion of tectonic plates moving away from each other can also create volcanoes too. This type of volcano is created as the plates separate. Molten rock from the inside of the Earth pushes upward and erupts through the Earth's surface. Who knew that so much was happening beneath our feet? Let's review what we have just learned. Question 1. Where are most divergent boundaries found? A. Ocean floors. B. Mountains. C. Valleys. D. Hilly regions. The correct answer is A. Most divergent boundaries are found on the ocean floors. Here's question 2. What happens to tectonic plates at divergent boundaries? A. They collide. B. They slide past each other. C. They move apart. D. None of the above. If you answered C, you know that they move apart at divergent boundaries. Question 3. Divergent boundaries can create which type of landform? A. Rift valleys. B. Volcanoes. C. Glaciers. D. A and B. The correct answer is D. Divergent boundaries can create rift valleys and volcanoes. What are transform boundaries? Our tectonic plates sure do act like bumper cars. Sometimes they collide. Sometimes they move away from each other. Sometimes they slide past each other too. A transform boundary is found where two tectonic plates slide past each other. These areas are also called faults. Every once in a while, the two tectonic plates get locked together as they are trying to slide past each other. The locked plates move together to try to get free. The energy created by their movement creates friction, which allows stress or energy to build up below the Earth. The place beneath the surface where this energy is stored is called the hypocenter. Eventually, the blockage will give way, and the stored energy is suddenly and violently released. When this energy reaches Earth's surface, we experience an earthquake. The point on the surface that is directly above the hypocenter is known as the epicenter of an earthquake. This is where the quake is felt most intensely. One famous transform boundary is the San Andreas Fault in California. This boundary occurs between the North American plate and the Pacific plate. The movement and friction between these two plates is what causes earthquakes in California. I am happy that my friend got to see the result of tectonic plate interaction up close. Now that we know these massive, slow-moving plates are still moving and interacting beneath us, we have a new appreciation for the continents, mountains, and volcanoes in our world. Well, now we know how earthquakes happen. Let's review what we learned about transform boundaries. Here's question 1. What is another name for transform boundaries? A. Glaciers. B. Plateaus. C. Faults. D. Hills. The correct answer is C. Transform boundaries are also called faults. Question 2. Where is an earthquake felt most intensely? A. The epicenter. B. The mountains. C. The ocean floor. D. None of the above. If you answered A, you know that the epicenter is where earthquakes are felt most intensely. Question 3. What is the name of the transform boundary in California? A. The Denali Fault. B. The Hayward Fault. C. The Seismic Fault. D. The San Andreas Fault. The correct answer is D. The transform boundary in California is the San Andreas Fault. Thinking question. How might modern technology help scientists track the movement of tectonic plates?